All right, this video covers evaluating functions. At the top here, I have defined what a function is. It's a correspondence that assigns to each element x of the domain exactly one element y of the range. You probably learned in class about the vertical line test. That's the way graphically we can tell whether we have a function. But this video is going to cover how to evaluate functions. So finding, stuff like f of 3, f of -6. And we do this by substituting for x in the equation. So let's just kind of jump right in here. So we've got this function, f of x equals x squared plus 5. And we want to find f of 3. So we're just going to substitute for x, the number 3. So I'm going to basically plug in 3 for x. And 3 squared is 9. And 9 plus 5 is 14. So f of 3 equals 14. Really what this means is that the point 3, 14 is on the graph of this function. So I know 314 is on the graph of f of x equals x squared plus 5. So really that's what the significance of that is. F of -6, same thing. We're going to substitute for x. When you square -6, you get 36. -6 times -6 is positive 36. And we'll add 5, we get 41. Okay, so I won't write it out again, but basically we just found that the point -6, 41 is also on the graph of f of x equals x squared plus 5. Okay, one more for this function here, f of square root 3. Same thing, I'm going to substitute square root 3 into the equation for x. When you square root 3, you just get 3. And 3 plus 5 is 8. Okay, so let me just show this real quick because it's been a while since we've talked about radicals. But if you're squaring square root 3, it's the same as multiplying it times itself. Square root 3 times square root 3 is not square root 9, and square root 9 is 3. So that's where I got this 3 here from. Okay, let's do something just a little bit different here. Just a little different. Now, instead of substituting numbers, we're going to substitute letters, basically. So we're going to find f of a, f of -a. You can see all of this here. This is going to kind of lead us into our next topic on this video, which is called the difference quotient. So f of a is the same thing. I'm going to substitute for x. Okay, so I'm going to replace the x in the equation with a. 3 times a is just 3a. And this is the answer I get, 3a minus 7. Those aren't like terms. I can't do anything else with that. So f of a is equal to 3a minus 7. That's it. Now we want to substitute -a for x. 3 times -a is -3a, and then minus 7. That's it. Now, the next one is negative f of a. I do want you to realize that these two are not the same. Okay, they're not the same. Okay, we're not going to get the same answer. Okay, so not the same. This one wants us to negate f of a. So up here, we found f of a, So I'm going to use my answer from the first example here and show it like this. So we're actually, this is saying substitute A in for X, but then negate that answer. So it looks like this. It's the same as distributing a -1. And so I get -3A plus 7. Notice that I did not get the same answer as f of -A. Okay, they're different. Okay, same thing with our last two here. They look alike, but they're actually not going to be the same answer. So same thing here, not the same. Okay, we're going to get two different answers. All right, so let's see here. F of A plus H means that we should substitute A plus H for X. Okay, so I just did that. I replaced the X in the equation with A plus H. I'm going to distribute the 3. And I get this. Kind of a weird answer, but that's my answer. Now this one wants us to find f of A and find f of H, and then add the two together. So f of A, we found it up here, and f of A is 3A minus 7. F of H would be found by substituting H for X. We would get 3H minus 7. Then we want to add these together. We do have some like terms here. You've got a -7 here and a -7 there. So answer here would be 3A plus 3H minus 14. Okay, again, notice that we did not get the same thing as we got in the previous example. Okay, so this is kind of leading us into a pretty big topic here called the difference quotient. The difference quotient is used in the definition of a derivative, which is a calculus topic. So those of you that are going on to calculus, you're going to see this difference quotient again. So let's just kind of jump right in here. We want to use this given function to simplify the difference quotient. So I'm going to start with this f of x plus h up here. Okay, so I'm going to start and try to figure out what f of x plus h is. Okay, first thing I want to mention here is that f of x plus h is not the same as, we just saw it above, not f of x plus f of h. Okay, that does not work. Don't do that. Okay, not true. Okay, this is bad. Bad, bad. Don't do this. Well, I guess I've shown that they're not equal, but don't try to do that. What this means is we're going to substitute for x, and when we substitute for x, we're going to substitute x plus h. It's going to look like this. It's going to look kind of crazy. Now I have 2 x's in my equation, so I'm going to substitute x plus h for both of them. And it looks like this. Okay, now I'm just starting. This isn't the difference quotient yet. I'm just trying to figure out what this part of the difference quotient is. Now I need to try to simplify this here. I don't want to distribute, not yet. By order of operations, you have to evaluate exponents before you multiply. So I can't distribute it, but I can square that binomial there. I'll go ahead and distribute all at the same time. So I'm going to, even though I could distribute the 3 right now, I'll go ahead and wait. Now I'm going to FOIL right here. And maybe I'll show it over here to show you what I would end up getting. Okay, so over here, I'm going to take x plus h times the quantity x plus h. And I'm going to get x squared plus xh plus xh plus h squared. Sorry, running out of room here. And that's equivalent to x squared plus 2xh plus h squared. So an xh plus an xh makes 2xh. Okay, so now back over here. So I've got 2 times the quantity. So I just figured out what I get when I take x plus h times the quantity x plus h. It's x squared plus 2xh plus h squared. And then I have my 3 times the quantity x plus h plus 7. Okay, now I'm going to distribute, and then I will have the beginning of the difference quotient here. So I'm distributing. Okay, so here's my f of x plus h. I do not have any like terms in that expression there. So I can't combine like terms. Okay, now it is going to be, we'll be able to simplify more because we still have to subtract f of x and then divide by h. So our answer is not going to be quite this long. All right, so let me move down the next problem so I've got some more room. All right, so we're still working with this one here. So our difference quotient is f of x plus h, which we just found, minus f of x all over h. So here's our f of x plus h. I'll go ahead and write it right here. All right, then I'm going to subtract f of x. Then I'm going to put the whole thing over h. When you subtract f of x, you're going to subtract all terms. Okay, let's go back up. I need to be able to see f of x here. So I'm going to subtract that 2x squared. I'm also going to subtract 3x. I'm also going to subtract 7. You're subtracting all terms in f of x. Notice that then all signs of f of x change because we're subtracting. Okay, so minus 2x squared minus 3x minus 7, all over h. Now you might notice that we do have some like terms and they do cancel, which is nice. So you have, maybe I'll use a different color here. So we have a 2x squared, and then later on we're subtracting 2x squared. That's good. We have a 3x, and then later we're subtracting 3x. And then we have a 7, and later we're subtracting 7. Okay, so we got rid of quite a bit once we subtracted f of x from f of x plus h. We are left with, in the numerator, 4xh plus 2h squared plus 3h. And we're going to divide that by h, and that will be our final answer. To divide by h, you could factor an h from the numerator, or you could just really take an h from every term. So final answer would be 4x plus 2h plus 3. Now notice that I still have an h in my answer because this was 2h squared. So I just took 1h from there, which left 1h. Whew, goodness gracious. Okay, that was a fun one, wasn't it? Let's do one more to practice. So I've got 3x squared minus 4x, f of x equals that. Okay, I'm going to start, first thing I'm going to do is find f of x plus h. And that means I'm going to substitute x plus h 4x into the equation. I have two x's, both of them get replaced with x plus h. Okay, then I need to square before I multiply. And x plus h quantity squared is x squared plus 2xh plus h squared. I showed that for the previous problem. So let me scroll back up for you just to show you. So I did it over here. So you can see that's not going to change. X plus h quantity squared is still the same. And then now I'm able to distribute. So I have 3x squared plus 6xh plus 3h squared minus 4x minus 4h. Okay, so my difference quotient is f of x plus h, which I just found. Then I'm going to subtract f of x, haven't done that yet, and then divide by h. Okay, so I'm just going to copy, here's my f of x plus h. Okay, then I'm going to subtract f of x. Doing that now. And put it all over h. Now notice when I subtracted f of x, I subtracted 3x squared. I also subtracted negative 4x. When you subtract a negative 4x, it turns to positive 4x. So that is going to be plus 4x. All signs are going to change in f of x when you subtract. All right, now I'm going to cancel some like terms here. I've got a 3x squared. I've also later subtracted 3x squared. Then I have minus or negative 4x. Later I've got positive 4x. Okay, so I was able to simplify that a little bit. Okay, left in the numerator is a 6x h plus 3h squared minus 4h. And the very last thing I need to do is divide those terms by h. And it works just to take an h from every term. Final answer would be 6x plus 3h minus 4. Another way to show it, if that was kind of confusing what I just did there, is you could factor an h from the numerator. And then you can see you've got an h here, you've got an h here. So that's another way to show it if you prefer it that way. All right, well, I hope you have a better understanding of how to evaluate functions.